So today we're going to talk about one of the coolest features or behaviors that we get with object-oriented programming, which is inheritance. And this is kind of what object-oriented programming is best known for, but we have been building up to it very deliberately over the last couple days. And as you've seen, even without like inheritance, there's an awful lot of power and functionality you can get from all these other object-oriented programming sort of language features, right? And in particular, just as a way to organize code and put data and logic together. And as your programs get bigger, think about how do I want to design it? What classes do I want to create to do what? What functions do I want to create to do what? So as with everything, it's just another tool in the toolbox. And Jordan, your demo this morning was awesome. And I saw you mentioning in the chat, someone was like, oh, why did you choose to use static methods instead of class methods? And you were like, yeah, well, I felt like I wasn't quite 100% on how my understanding of class methods and static methods I understood better, and they got the job done. So I went with that. And that is 100% the way to go. There's almost always more than one way to do things. And as you've seen, like Jordan, the code you wrote was super readable. Other people could understand it. It made sense and it met spec. So those are by far the most important things. And then like best practice questions around should I refactor this to be a class method instead of a static method and so on are good, but icing on that cake. And this goes with all of object-oriented programming as well, right? Lists don't go away, dictionaries don't go away, and so on. And as we see inheritance, that's going to be true with this as well. Inheritance is super powerful. It is just another tool in the toolbox. So we're going to talk about what inheritance is in object-oriented programming. We're going to see how a class can inherit its behavior from another, and we call that a child and a parent class. A child class inherits all the methods and attributes from a parent class. We're going to see how to use inheritance. We learned about instance versus class methods yesterday, and we'll see that and do a bit of review of that again. We'll dig a bit deeper into inheritance. A child class can inherit from multiple parents. And we'll talk a little bit about when should I use inheritance versus, say, a composition approach where I have maybe 2 or 3 classes and they use each other. Like maybe one class creates an instance of another class, but it's not actually inheritance. And this will show up on the assessment that we're going to release tomorrow. So let's just do a little bit of a review and put together some classes before we dive further into inheritance. And let's use the examples of like cats and dogs. And can someone help me out and maybe navigate in creating a dog class and just walk me through a couple of the steps? Just a really simple dog class, nothing fancy.
You would have to construct it with the init, right?
Yep.
Definite, and then and then
Yep.
you'd want to put some attributes for
Yep.
the dog.
What attributes do you want our dog to have?
Um, the the breed, maybe.
Sounds good.
Maybe their name.
Sounds good. That's a good start. And I'll go ahead and create some instance variables.
Wait, should that be self.breed breed?
Yeah, that totally should be. Thank you.
Okay.
Right, so we now have some instance attributes when I create a new instance of a dog. And Nika, what would you like our dog to do? What are some methods that we can make for the dog?
I don't know. I mean, you should teach him some tricks. I don't have a dog. I've never had a dog. Roll over, I guess. I don't know.
I love it. What do you want the dog? What do you want the dog to do when they roll over?
I don't know. Um, I don't know what they should do when they roll over. That they pants or something. I don't know. What does the
Yeah,
dog do when they roll over?
you can phone a friend if you want. Um,
Anybody else want to jump in? Please feel free.
He should roll over when he rolls. Like
The
the
dog.
rollover should cause him to roll over. Which, yeah, you could just print like
Like
he
for self.
rolls over, pants wags tail. Yeah,
Roll over and then waits for a treat.
Oh,
yeah.
that's a good idea.
Okay, I love it. Rolls over and waits for a treat. Yeah, and Nika, any other anything else you want our dog to be doing?
I don't know. What else could the dog do? I'm sure dogs will bark.
Yeah, totally. I think it's a good one. Yeah, and anyone else, any requests for dog behaviors to put into the mix?
Dances or does a trick.
I'm sorry.
I said dances or does a trick.
Dances. Okay, you're gonna have to be a little more specific. Which one do you want?
Let's just do yeah, let's do dances.
All right, I love this.
Yeah.
And we can kind of follow this pattern that we established of dances and waits for a treat. I love it. All right. And could I get a volunteer to navigate and help me create a cat class?
You could just start doing class cat.
Yeah, I think that's a great start.
And then do the def init.
Yep. And what arguments do you want to pass our constructor?
Self, and then breed of cat, and then the name of cat.
Sounds good. And so we've got self breed equals breed and self name equals name. And what do you want our cat to do?
They can purr. So we'll do def purr self. We can print like the F string with the cat's name saying it's purring, is purring. Yeah.
Okay. Yeah. And what else do you want the cat to do? And as always, you can phone a friend.
The cat can also use the litter box.
Yeah, I think that's a really important thing for cats to be able to do. And do you want something just like printing like cat uses litter box?
Sure. We could also have like I don't know, what's that other thing? Like litter box is dirty, and then that makes it, you have to clean it afterwards.
Okay. Should we implement that as like a feature?
Could
I
you,
kind of like that.
yeah, what is it called when you put hold on, I gotta look at my notes. The class attribute.
So is every single cat going to share one litter box?
Usually,
Not always.
not always.
Yeah. If all the cats are in the same house, yes. And so if we were writing a program that was just for cats that like, you know, live together in the same house, then they would share a litter box. And I think making anything litter box a class attribute would make sense. But if we were writing this program for cats that live in many different places, then they probably have different litter boxes.
Gotcha.
Yeah. So that's a design decision. I'll just make the call that the cats will live in many different places. So let's make a feature where the cat, every time the cat uses the litter box, like we track it, and then when the cat uses the litter box a certain number of times, the litter box is now dirty. So can you navigate me through building part or all of that feature? And as always, you can phone a friend.
Um, let's see. thinking. So would you have like the litter box outside of the class then? And then, or I'm trying to think.
Good question. Let's
Phone a
keep the
friend.
litter box inside the class for now.
Gotcha. Kara looks like she got some input.
Kara, yeah, what's up?
Sorry, I wasn't clicked in. Would it be helpful to have like a house class that you could then assign pets to, and then have a litter box within the house?
We totally could. Let me think about that for just one moment. I think that would be cool. I may come back to that one later. And that is exactly the kind of design decision we want to be thinking about. For now, in the interests of time, let's say that we are only going to worry about a litter box for cats. The litter box will be part of the cats class. And the behavior that we want is that when the cat uses the litter box 3 times, our cat class prints a message saying like, the cat says the litter box is dirty.
So then could we set like an empty integer to 0, like litter box equals 0, and then whenever the cat uses the litter box, it would be like litter box plus 1.
Yeah, where should I create that integer?
I want to say above all your functions there, but inside the cat class.
Right. So let's assume that every cat has its own litter box.
Okay, gotcha. So maybe we make another, or maybe inside the litter box. So there we can just kind of put litter box equals 0, and then after the print statement, we can do litter box plus 1.
So we can do this. In general, whenever we're creating variables that are for like specific instances, we
Right.
probably want to create them in the constructor.
Okay.
So because this way, right away, when I create a cat, there's a litter box and it's set to 0. Now what would I do? What's the logic I want to add when the cat uses the litter box?
Self.litterbox plus equals
Yeah,
1.
exactly. Right. And let's go ahead and test this out just so we can watch this in action. And so, Kara, I love the idea of a house class. I love the thought, like, do we want a litter box shared amongst multiple cats? And would we want to do that with like a house class or as something on the cat class instance? But I just wanted to point out, you know, if we just want to like get a toy litter box feature going for an individual cat, this is actually like a really simple and straightforward way to go about it. And once we have this done, this is a great prototype for us to build on. And let me go ahead and run this code. And I want to pause and check in and see if folks have any questions. So now that we've got the litter box, can someone navigate me through adding some logic where after a cat uses a litter box 3 times, the cat says that the litter box is dirty? I see a couple hands. By the way, you know, when I'm asking questions to the whole class, feel free to jump jump in, but I see a couple of hands up. Mike, yes, sir.
So right under that print statement where you're at, you could just do a very simple like if litter box yeah, right. If self dot litter box, you know, is more than or equal to 3, and then yeah, more than or equal to 3, then and then put your print statement there.
Yeah. And actually, I liked that you added more than equal to 3, because that gives us different behavior, right? I was actually just thinking equal to 3, but then we only get it the once. We wouldn't get it each repeated time, but you're absolutely right. The cat would be complaining every time they use the litter box. And Mike, could you navigate me and let's create a clean litter box function so that for cleaning the litter box. And as always, you can phone a friend.
Okay, so you would just say okay, so on that one we've said that it's dirty. So you could just, I mean, could you just do another one like if, you know, if it, so now it printed, right? So could you just do another if then that if it's dirty, then you would just have an action print owner cleans the litter box?
Sure. And I mean, if we want to, we could put it just right here and say like owner cleans litter box. But let's say I want to separate this out as its own method that I can decide to call whenever I want, because maybe it's a really busy day and I can't get to the litter box right away.
Okay, so then you would just same deal, just so you would delete that line and then just create a new method, and you could just call that clean litter box. So define clean litter box, you know, input self, and then print owner cleans the litter box. And then you could just, now that's there, and you just call that based on whatever condition you have anywhere else.
Yeah, let's go ahead and run this. And it's a little ironic because it's not really Garfield that's cleaning the litter box, but that's okay for our purposes. So I cleaned the litter box, but it's still dirty. What can I do to fix this problem? Terrence, yes, sir.
I was gonna say, can we reset self.litter box to 0?
Yeah, exactly. We got halfway there on the clean litter box method, right? And then we both want to maybe print a statement to the user, but we also want to reset our litter box counter to 0. And now the litter box is reset, right? And again, there's a lot of, I think, good design questions around, like we could create a house class for this. And I think that would actually, it could make a lot of sense. That dramatically expands the scope of the program that we're writing. And in terms of just getting a feature out the door and having like some core logic for us to look at and see, this is a good start. And I just wanted to kind of walk us through a review of like using the tools that we know. And I just want to pause and check in and see if folks have any questions around this code that we've been writing. And let me check the participants channel and Roger, yes, sir.
I am a little lost on I guess being used to JavaScript, I guess, where the return would be. Like how am I seeing it in the terminal other than print? Well, if a final product is happening, do I not return anything? I just see it print off and That's it.
In this case, because we are updating instance variables on our class, this is doing the work of updating these values. And
Okay.
these methods don't have to return anything, and then the print statement prints to the terminal. And hit me up after class and we can go over this in a bit more detail and talk about some of the differences of this versus JavaScript.
Thank you.
Absolutely. So we've got a cat, we've got a dog. They have some similarities, right? They both have a breed, they both have a name. They both can do stuff, right? They make sounds. The dog has some tricks. The cat, in fact, maybe let's have the cat clean their own litter box. And the only reason I'm doing this is so that I like the idea of the cats being a little more independent than the dogs. Though a cat obviously I guess would not do that. They would complain until the owner did it. So actually I guess I'll just turn that back. So the cat has this whole litter box behavior that's totally different. The dog just goes in the yard, right? It never needs to be cleaned, so to speak. So there's some similarities and differences here. Inheritance lets us create a parent class that other classes called child classes can inherit with shared behavior. And here the example is the idea of a phone class that is inherited by an iPhone class and a Nokia class and a Motorola Razr class or something like that, right? Like or it'd probably be smartphone, flip phone, brick phone, right? Because maybe it's a little more specific than brands. So let's put this in action with our cats and dogs. Let's make a class named animal. And let me go ahead and write this out and show how this inheritance works. So I just write a normal class. We don't have to do anything fancy with the class we want to use as a parent class. And for animal, we'll use breed instead of species since that's what we have for the cats and dogs. And I think that's fine. Though we could get even more specific if we wanted, but and the animal has a name. Every animal has a breed. So our dog can inherit the animal class, and our cat is going to inherit the animal class. And so this is the first thing you do when you're using inheritance is you tell a class what other class we want it to inherit like logic and behavior from. And so for my dog, and let me get the cat off the screen so we don't have to look at it at the moment and we can just focus on the animal and the dog. Animal has this property name and this property breed. So I don't need these here. What I can do is use this special function that Python gives us for classes called super and call it. And what this does is it calls, it lets us access methods from our parent class. And I think what I will do is let's add species here so it makes a little more sense. Oh, I'm so sorry. That would help if I put this in the right spot. And we haven't made a dog yet, so let's go ahead and actually make a dog. So let me go ahead and comment out all my cat related stuff for now.
I have a question real quick. Why would you put the dog in quotes when
Right.
you're doing super?
Good question. Give me just one moment and I will come back to that. And I'm going to give my animal class a dunder string method as well. So we can get some information about it. And let's run this code and see what we get and talk about what super is doing and what I'm doing here on line 13. Let's see here. str return non-string type. So my error message is telling me the error is on line 25. If I look at line 25, that's my print statement. The type error is telling me this method underscore str. So because I know that what a print statement does when I print like a class instance is use its str method, I know that the bug is somewhere in my dunder str method on my animal class, and it says it returned a non-string type. And if I look at what this method is returning, it's not returning anything at all. And that was a mistake that I made because when we create the dunder str method, since that's like a special method that needs to follow a pattern set by Python, it needs to return a string and not print it. So let's see what just happened here. I created a dog. The breed is Labrador. The name is Fido. The species is dog. I print Fido. My dog class doesn't have an str method, right? But the animal class does. My dog class was able to inherit all of the methods of its parent class, the animal class. And the animal class has these instance attributes, species, name, and breed. And I didn't have to define them in the constructor and assign them to self, but I can still use them. Right. And just to prove that species and name are here, I'll add these to my f string. I'll add these to the bark method. Right. And I can see that even though I don't assign these instance attributes to self in the constructor here, because I do it in the parent constructor class, I get it in the child one that inherits from it. And super is how I call the constructor of that parent class. And if I don't have super there, a whole bunch of stuff is going to go wrong. right? And suddenly it says dog has no attribute species. So the same way that when you create a new instance of the dog class and we are passing arguments into the dog's init method, when I have a child class that inherits from a parent class, I almost always want to, in the constructor of the child class, call the constructor of the parent class to instantiate a new instance of animal that is also a dog. And so this first argument here that we pass in, this is the species, right? Like if I put armadillo here, then
Sorry,
suddenly,
Adam, just real quick.
yeah.
I think Saul had a question.
Oh, yeah. One moment, Saul. So to go back to the question from a little while ago of why does this say dog? It was sort of just coincidence, essentially, that this string dog matched the class name. This is the first argument of the constructor for our parent class, which is the species of the animal, right? So if I wanted to create like armadillos, I would say, hey, this is an armadillo. But since our dog class is for dogs, and since naming things in similar ways can make our lives easier, I set the species here and the class name is dog. I think it was Crystal that was asking about that before, but I'm not sure. Does that help explain why I've added dog here as a string in my argument?
Yes. So like anything that we're inheriting from the parent class, we write it in like a string format.
No, we are calling this constructor right here on line 25.
Okay.
So think of this as if I was to make a new animal, I would do that, right? And this first argument, the string dog, that's the value I'm passing into this argument here in my constructor. If I wanted to make an armadillo instead of a dog, I would change the value of this and pass then that in as the argument. But because I don't want to like create an instance of the animal class, because I am telling Python, have this class dog inherit all of the behavior, use the animal class blueprint and build on top of it for a new blueprint, I want to call this constructor as a part of my dog class, and we do that with super. So for instance, for our cat, this would be cat. Or if I decided that the species name is feline or whatever the name of a cat is, I would put the species name right there. And Saul, I know you had a question as well.
Yeah, real quick, I just wanted to ask, will the attributes of the parent class ever like clash with the attributes of the child class, or do they just trickle down onto each other?
That's a great question. You mean what if I did self.species equals that, where I have it defined here and I have it defined here?
Mm-hmm.
Yeah, let's see what happens. So note that what happens here is I can do this, Python doesn't complain, and this just overrides whatever's in the parent class because this happens later. If I put this first, then this would happen, but then we call this and it overwrites the property of self.species. This is actually called polymorphism, and you actually want to do it with methods sometimes, but we'll talk about that later.
Awesome, thank you.
Absolutely. Yeah, I see a bunch of hands up. I just want to make sure the questions are related to what we're looking at right now with sort of classes and inheritance. And let me just kind of run down the list. Nika, yes, what's up?
Quick question. You said that you pretty much would use super anytime. Is there any time we wouldn't use it? Or is that going into the weeds too much?
That's a good question. The reason you almost always want to use super is because almost all the time when you are using inheritance, you probably want to call the constructor of the parent class, right? As you get more advanced in object-oriented programming, sometimes maybe you have a utility class or something where you actually don't need the constructor of the parent class, but that's less common and you won't encounter that in, I don't think it's on the assessment or really any of the code you'll see in this course. So as a rule of thumb, I would just always do this because you almost always want to use it. And if there's ever a time where you didn't, you would know. Does that make sense? Sort of, yes, no?
Yes, no, you're good. I put a thumbs up, but yes,
Oh,
you're
I
good.
missed
Thank
it.
you.
Awesome. Yeah, great question. Thank you. And Natalie, what's up?
So is it just a coincidence that you have the dog attributes almost the same as the animal class attributes?
You mean
Or do
here
they,
and here and here?
no, in your init method, you see it's self, breed, and name, and then also for the animal class, it's like species, breed, and name.
Right. So the goal here is I create a dog. I call my dog's constructor. I pass the values of what I want when I create a dog for the dog's breed and the dog's name. And so when I run my code on line 37, Python looks at this, says, cool, let's call the dog class constructor, pass the string Labrador and Fido for breed and name. And then Python says, oh, wait, dog class inherits from another class animal. As a part of the dog class, I'm supposed to create an animal class that the dog will belong to. And this animal class, okay, let's call this constructor function. Oh, my animal has a breed and a name. And what is the value of Fido's breed for the animal class? Labrador. And then for Fido's name, it's Fido. So because the whole goal of inheritance is to have shared behavior from parent to child classes, a lot of the times you'll have instance attributes here that you can pull in here. For instance, like here, the animal has species. I don't define, this isn't something that we pass in here because we're just hard coding this, but we do want this flexibility so that I can like create different breeds and names of dogs.
So since your animal class already has breed and name, would you not be able to give your dog class like different attributes since the animal class already has breed and name?
Great question. We absolutely could give our dog class its own attributes if we wanted to. Like we could do I'm trying to think what's a quality is a big dog. And I actually, my folks have standard poodles, which are big dogs. But for the purposes of example, we absolutely can, and we often do want to add instance attributes that belong to the child class and not the parent class. Terrence, yes, sir.
I was just this might have been answered already, but I'm just kind of confused. So now that dog has been like hard coded into the init method of dog, so now like you don't have to put anything in for that argument. Like before it was hard coded in, we actually had to put something there, but now we only need to when we instantiate a dog, place something in for breed and name.
So if I don't hard code it in here, and so let's take a look at what's going on here, right? With super, we're calling the constructor of the parent class. We're calling this init method. This init method takes 3 arguments, right? Species, breed, and name. When I create a new dog, this calls the constructor of my dog class. So how do you want me to tell the animal class what species it is in? How can I get the value for this species argument into this constructor? If I run my code right now, I get an error, missing positional argument. This first argument here, Labrador, goes to breed, which gets passed in here, which gets passed in here. The second argument, name, gets passed in here. Well, actually, breed, it would go to species, which isn't right because this is the first argument here, but it's the first argument here. So, like, I think the important thing to remember is methods work like functions, other than self, which is sort of special, and Python passes it in. And functions, we're just passing in arguments, right? And this is just a function that takes some arguments, and then we call another function, and we're passing some of those arguments on. So, like, if I really wanted to, I could do this, right? Species, breed, name is a big dog. And then I could do this. And now when I create a dog, I pass the species in as an argument here, which we then pass in here as well. And this one breaks for the other one for noodles because I haven't done this. But since the whole point of like parent-child classes and inheritance is to not have to like write a bunch of duplicate code, and since I know that every single dog I ever create will belong to the same species, I want to hard code that argument in when I pass it to the constructor for the animal class. Does that help? I know that was a bit, I covered a lot of ground there, but does that help clarify a bit of the behavior of what's going on?
It does. I think I'm just gonna have to mess around with it to really get it to sink in. Thank you.
Yeah, totally. I think the important thing here is this is just a method. And this is just the method. And understanding like what arguments am I passing into my method and what happens to those arguments, right? And when I do this, I'm calling init and I'm passing in these arguments. And then this calls this other init and I'm passing in these arguments. Mike, yes, sir.
And then just to clarify, just kind of the opposite of the previous question. So when you inherit, you can always add more to the class that's inheriting from the parent class, right? But you can't use less. Like, so I couldn't basically call animal and decide, hey, I don't want to use breed because breed's in animal. I couldn't just like pick and choose. I got to use all of it, and then I can add to it with the child, but I can't just cherry pick from the parent. Does that make sense?
Yes, you're basically correct. That said, you know, if the animal has something in the constructor like is reptilian, like, and we do like self is reptilian equals is reptilian, like this is in my constructor now. Or let me just create a method here. That's going to be a better example. Like, let's just do a def special animal method self. You're correct. Dog inherits from animal. So it has all of the instance attributes and methods that the parent class does, but I can always just choose not to use it. So just because it's there doesn't mean you have to use it. Mike Ray, yes, sir.
Um, yeah, I mean, I just want to make sure. I think I get it for the most part. So like line 41, whenever you're making that instance of dog, you're passing those three arguments to the line 26 class dog, and it's going to return because you're calling it, it's going to be the dunder in it. So you're going to pass Labrador, Fido, and True to self, or yeah, to breed name and is a big dog. Animal,
What's
like
your question,
I guess my
Mike?
question is like, so animal links them so that it's inheriting, but then super is what kind of lets us when we're passing a dog breed name, it passes from that, like what we pass into the dunder in it. So like, so the
Super, yeah,
Labrador to 27, then 27, it passes in the breed to 28, and then that allows us to have the assignment of the class animal, like self.species will be,
yeah.
dog and
I
name
see what
and
you're
breed.
saying.
Is that what it is? Like the logic flow, I guess?
Yeah, exactly. This stuff gets passed in as arguments to here. And then exactly like you're saying, we use super to call the constructor of the parent method. So then this stuff here is passed in as arguments here.
Gotcha.
Kara, yes, what's up? And then I need to continue on.
Yeah, sorry, just real quick. Just following on with what you were talking about. Um, oh goodness gracious. I think I lost my question anyways. Go ahead. Move on with that.
Okay, no worries. I have a quick question, folks. How many folks read the curriculum for today, yesterday? Awesome. I'm glad that a lot of people are doing that. Please continue doing that. And that's useful for me to know too, because then that tells me, okay, we should be spending this amount of time and going into this much depth on stuff. And I apologize. Yeah, what's up?
No, I just remembered my question. I'm sorry. I just wanted to know, logic-wise, as far as thinking about constructing your classes, if you have a lot of methods or attributes in your parent class, is that some sort of indicator to you that maybe it shouldn't be in your parent class and it should be broken down
No,
out of
not
that?
necessarily.
Okay, cool.
Yeah, it's just going to depend on the situation. Awesome. I do want to show, so we can do multiple inheritance, though we do it less often. Let me go ahead and demonstrate this, and then we can get some hands-on time with this stuff, which I think will help nail it down as well. Give me just one moment to jump to where I want to be. Yeah, and again, these are good questions. I apologize if I'm a little swift sometimes, and it's only because we have limited time. You all will want to be spending a good amount of time writing code to get comfortable with this stuff, and I'm glad that folks are reading through it and working through the material like a day in advance. And if you haven't, I would encourage teams to maybe start forming like study groups or review groups, or do that amongst yourselves. Just because we are going to be covering a lot of ground over the next 12 weeks. So we're going to be doing this, and there will be continuing to learn and do more stuff. So let me go ahead and add some more inheritance here, because we've done all this with the dog, but we haven't done much with the cat. Right? Well, the cat, we've done the basics. We've got Garfield, and let's just print Garfield so we can watch this thunder string method happen to see the Garfield description. And let me comment out my dog stuff. And so, right, I've created Garfield. I use print, which uses this thunder string method here on the animal class. So I can see that the cat inherits from that as well. And in fact, I'm going to do a little bit of refactoring. Let's call it like make sound. And let's pass in an argument here, sound, which will be the sound that the animal makes. And this will just be a simple F string that just prints the sound. And let me go ahead and modify my cat class. And actually, well, let's do the dog since we were looking at that more. And actually, could someone maybe navigate me and I'll drive? How can I modify the dog class now so that we can use this make sound method that the animal class has, right? We have bark. We're going to want to maybe replace bark with just make sound. Landon, yes, sir.
You could define a constant within the dog class, and you could above the init line,
Okay.
yeah, all caps, just call it sound equals, and then you can call the parent method there. You could set that const to the parent method make sound, and then you can call that constant somewhere in a method within your dog class.
So I sort of see what you're saying. Let me get rid of Bart just for the moment. So let me go ahead and let's do Fido.make sound. And let me get rid of the Garfield stuff. And it would help if I closed my print statement in the animal class. So I've got an error. It says type error, animal, dunder, init, missing one required positional argument, sound. Landon, can you help me debug this? And as always, you can phone a friend.
Yeah, you're not including it in your init.
Which line of code?
29.
Like that.
And then you need that in your super as well.
Yeah, exactly.
Line 30.
Awesome. And so now I run my code. Now I get a type error, and it's almost the same. It says dog init missing one required positional argument sound, and it's coming from line 40 right here. So what can I do to fix this problem?
It requires another argument. So after true, you need to add a sound or sound.
Do you want me to do dog dot sound or bark, or what were you thinking?
That should work. I thought you were trying to access the method from the parent. I posted in the Zoom chat how I would use the sound.
Got it.
Yeah.
Yeah. So we could do this, right? And let's see what happens here if we do this. And let me comment out all the cat stuff actually, because that's what's causing the error. I could, if I wanted to make life simpler, I could even do this. Right, but this is a little annoying because now every time I create a dog, I have to say what the sound is, when my goal is all the dogs have the same sound. So you're absolutely right that one way to like set a constant that's like connected to the dog class is to use that class attribute. But since what we care about here is what we pass into the constructor of the parent class, I can just do that. And now I don't need to have this be an argument at all. And now all my dogs make the same sound. And could I get another volunteer? And Landon, that was awesome. Thank you. Could I get another volunteer to help me refactor the cat class so that our cats will purr when we call the make sound method? So right now, if I create a cat and it's I'm not species, breed, name, sound. Let me get rid of this true false, which we don't really need for anything anymore. And let me go ahead and run my code to make sure I'm getting the error that I want. Oh, I do need that. I'm so sorry. That's the is a big dog argument. I totally forgot. Please forgive me. Okay, awesome. So, I create Garfield, and I get an error missing one positional argument sound, and let's put the Garfield dot make sound function call here. Can someone help me debug this problem and get Garfield to make a sound?
Wouldn't you add the like meow to the super init method on line 61?
Yeah, exactly. Right. This constructor method needs something to be passed in as an argument because I want all cats to make the same sound. I can just hard code the thing that I want to pass in as an argument for sound right there. And now Garfield makes a sound. Let me talk a little bit about multiple inheritance just so that we can see it, though we will do less of it. This stuff is really the more important stuff. And actually, before doing that, let me quickly, just to sort of do a little bit of illustration here. Let's look at the classes that we've created. Wait, sorry. We have cat and we have dog. And they both inherit from the animal class. And the animal class has self.name, right? Self.species, self.breed. And then it has the methods make sound.
Should one of those dogs squares be cat?
Oh yeah, one of those dog squares should totally be cat. Thank you so much.
Mm-hmm.
Let's have that one be the cat. I'm just gonna make sure I didn't miss anything for our animal. And I did indeed. The animal has a sound. So the dog and the cat class get all of these things. And then our dog, we also added if it's a big dog, right? And so that's an attribute that only the dog class has that the cat class does not. And dogs can roll over and dogs can they dance. And then cats can use the litter box and clean the litter box. And then cats also have the instance attribute of self-doubt litter box, which dogs don't have, right? And which the other animals don't have. So this is the relationship between our classes of our parent class and our child classes. Now, what we can also do, though this is less common, is you can have multiple, one class can inherit from multiple classes. I do want to demonstrate this, and then we'll go over the workshop assignment and have a solid 45 minutes to take a break and work on it. Multiple inheritance is less common, and I want to demonstrate it and talk about it more so that you see it, and also to just help illustrate the general concept of inheritance and what's going on here. So let's say that let's just give them both names, and let's give, I think the mother should have let's say like favorite book, and let's say the father has favorite movie. And the child class, I'm not going to add anything to right now. And I'm just going to code this up very quickly. So I want to create a mother class. I've got a dunder init method. And for mom, they'll have a first name. Nobody has last names in this universe, and a favorite book. And then for dad, there's a favorite movie instead of a favorite book. And then for the kid, we're not going to pass in anything extra. Actually, how about favorite play? And I'm going to give the kid a dunder string method, so when we print them out, we can get some nice information about them. And the child is going to inherit their first name from their parents, and there is going to be a conflict here that we'll see in just a minute. Inherit a favorite book from their parents. And this F string is getting a little long, so I'm going to make it a doc string. inherit a favorite movie from their parents, and from themselves, their favorite play. So, you know, I can create my parent classes. Oh, and I'm so sorry. The child, of course, will need to be a child class and actually inherit from these other classes. So I want to inherit from both of these other classes, and I want to call the constructors of both of these other classes. And in fact, for the child, we need to pass in well, it depends how we want to do this, right? It depends how we want to do a little bit of name setting. Let me do a little bit of refactoring. I apologize. And after this, we will jump to the assignment and take a break. What's a movie that starts with B? Let's do those. And when we create the kid, they get a favorite play. So this is a little bit of a contrived example because these things are hard-coded, which doesn't make so much sense for classes. But I want to illustrate just the behavior of multiple inheritance. So we can't call super here because we don't know which parent class we would be calling this dunder init method of. So we need to explicitly tell Python, call the dunder init method of the father class, call the dunder init method of the mother class. And then over here, and the favorite play is going to be so there's a couple interesting things that's going to happen here. And I know this is a little weird because the child doesn't have a name and the parents do, and kids don't inherit their parents' names. But I just want us to take a look at a little bit of this behavior. So let's see here. Father init missing one positional argument, required positional argument self. So actually Python is giving me a really good error message here. And I actually do need to pass in self for multiple inheritance here. So the thing I want to point out is what happens if we change the order. Someone was asking about like attributes overriding each other. Mom has a first name, dad has a first name. Depending on the order in which we call these, one overrides the other. So multiple inheritance is a bit more complicated, and you're not going to need it most of the time. And I would honestly recommend avoiding it. And that's true for even professional development work. Like with inheritance, simplicity is the way to go because it can get complicated really quick. The obvious benefit of inheritance is reusability, right? We started to see that a little with the animal and the cat and the dog classes, and consistency as well, and some modularity. Best practices with inheritance is, again, simplicity. Try to have each class have a single responsibility. You can do multiple levels of inheritance. Like you could have, dog inherits from animal, and you could create a Labrador class that inherits from dog. That gets very complicated very quickly. I would recommend avoiding that, and there shouldn't be a reason you need to do that. Similarly, while I wanted to demonstrate multiple inheritance to help illustrate a bit of what's going on, I would recommend avoiding it because you don't need it most of the time either. It's usually easier to write, have a little bit of inheritance mixed in with like all of the other techniques that we saw. So I know I've been going for a while, so let me just introduce the assignment I want you all to work on for a bit, and then we'll break and have about 30 to 40 minutes where you guys can start writing some code to get your hands on this. So the goal here is to just create some zoo animals, and we've laid out some classes that we want you to create. We want you to create an animal class, and then give the animal class a name and a species attribute and a method, very similar to what we saw. And we want a mammal class that will inherit from animal, and the mammal class should have its own method, give birth. And then we want you to make a bird class that inherits from animal and a reptile class. And then we do want you to do a little more subclassing if you get here, to actually do one layer more of, let's create a primate that inherits from mammal and a marsupial that inherits from mammal as well. Part 3, I think, is a little bit of a stretch goal. If you get to here, great, but if not, no worries. So now's, I think, a good time to break, and let me go ahead and pause the recording.
Okay, so we started out, here's where we initialized our class animal, and Purple Cobras, feel free to jump in whenever. I'm just gonna start going, but definitely a free for all if anybody wants to add anything. So we initialized this class animal, set this up. We have this speak method here. And then this class mammal inherits from animal. And then we added the give birth method here. And then here are our two subspecies of mammal. So primate and marsupial. So they both inherited everything from animal or from mammal. And then we just added, they had the one method each. And then here we created the bird class, which inherits from animal. So that gave us the name and species. And then we just needed to add wingspan as another attribute. And then here's reptile again, inherited animal. And then same thing, we just used super to give us the name and species. And then we just added what we needed, which was this method here, bask in the sun. And then we created this aviary list that'll push the birds into, and then the reptile enclosure. And then as we went through this, we just looked at the test suite just to make sure that we had everything that would conform to the test. And then I can run it again.
Yeah. And where were you using the aviary class, by the way, in the code?
It's right here.
Oh, did we get to the point where, like, are you creating an instance of the aviary class anywhere? Or if
We
that's,
didn't see that in the README. We didn't get that far.
got it. I apologize. That's my fault. I think that's just outside scope. Sorry for the confusion.
Yeah, we were just going through the pie test and trying to make sure it passed all the tests. But we were definitely, when we were talking about it, is like we would have to have some sort of function that when it creates the birds, it would pass it into the aviary, or the reptiles into the reptile enclosure.
Did you
That's
have a
the way to
question?
do it.
Athena?
Exactly.
I think
Yeah,
Athena.
so
Yeah.
from the way that I was like understanding the README, is the class aviary not supposed to inherit from birds? And that could, I just want to make sure that I'm understanding like how to read specs and whatnot, because it doesn't say specifically, it just they. I don't know.
I think the intent and like the way we were gonna approach it was inside the bird class. Every time that bird is instantiated, it will add its name, species, wingspan, attributes in a list to the the aviary birds list, if that makes sense.
So your bird class calls the aviator class?
We didn't get that far, but
Yeah.
that was kind of our initial
Oh.
approach of what we were thinking about doing.
So
Sorry.
Can I ask a question and like everybody chime in? So in the just so because I explained this to my team and it could be wrong. In the class aviary and reptile enclosure, if we just passed in self and set self.birds to an empty list and self.reptiles to an empty list, does that do the same thing that's happening right now with the default as an empty list?
I want to say no.
let me jump in here. It would,
Because we got it to pass that way as well, but I don't know if one way is right, one way is wrong. So that's what I'm trying to clarify.
yeah, actually, let me go ahead and share my screen here because I'd love to dive in and address both these questions real quick. And that was an awesome demo, Purple Cobra folks. Thank you.
Good job, Purple Cobras.
Yeah, let me go ahead and make sure that I'm sharing my screen. And let me tackle both of these because these are great questions. So let me just make an aviary class real quick here. And it's going to look something like this. And the question was, right, what is the difference between this and this?
Yes.
Right? And the difference is, and let me make a bird too, just so I have it. And I'm not gonna, just for the interest of time, I'm just not gonna worry about inheritance or anything like that. Just so the bird has something. So and Athena, I'll kind of dig into your question a bit more in a minute as well. This will sort of set up a good prelude for us. Oh man. What's some bird name from like a movie or something? Iago from Aladdin.
Rio.
Sorry?
I said Rio.
Rio.
From,
Okay. I love it.
I forget the
Big Bird.
Right. So there's a lot of different ways to use the aviary class, and this was outside scope of the assignment because we didn't talk about it. It would really depend how the rest of your program is designed. Maybe all of this is in like a different file, main py, or maybe here, and we're just running the whole code here. It could be inside a completely separate function or a completely separate class. It depends how you write your code. So to answer, I think it was Roger's question about, well, what's the differences? So the first thing to think about is how do I get birds into the aviary? Well, I can do my aviary.birds.append, and I can add Tweety, right? And I can do this whether I write my code the way it is here or the way it is here. The difference is by allowing me to pass in a list in the constructor if I already have some birds. Let's say just maybe for whatever reason. when I create the aviary, I can pass those birds in, right? Because this list is this argument passed into the constructor. And if I get rid of that, then there's an error. Or this would be an error because the constructor isn't taking any arguments.
So if you did it the way that it is currently and put an add method, is
Which method?
if you made an add method to add to that list.
Oh, so like this.
Yeah.
Yeah, so I can.
And okay. All right, that's cool. That's cool. You don't have
Yeah,
to dive
exactly.
into it.
I can totally do this, right? And then I could do my aviary add bird. And this is in fact probably what you would want to do really for both of these. The difference is when I create the aviary, do I want to be able to pass in some birds then or not? That's the big difference, because this way the way we have the code now, I cannot, right? Because this init constructor method doesn't take any arguments. But if I decide that the way I'm running my program, I do want to be able to do that, then by doing it like this, I don't have to, but if I want to, I now can pass in a list of birds. And to go to your question, Athena, on how to use this stuff, this is actually a great intro to talking about composition versus inheritance, which is what we are gonna do next. So you raise a really good point, which is, hey, how do I want these two classes to work together? And there's a couple options. One is, again, maybe this is all just in the main method of my code. Or maybe I create a function and I decide that it's and so in the main method of my code, I create my aviary and I decide I want to write a function whose job it is to create the bird and add the bird to the aviary. And then whenever I want to make a new bird, I have to follow the pattern. And in fact, we should return the bird because we probably want to do something with it. Doing this, right? But and this is perfectly fine as well. And you all sort of saw me taking this approach with the car manager yesterday. If we want to lean more into object-oriented code, maybe we do want to do something to our bird class, right? Maybe we want to do something like create an aviary, and it would help if I defined the aviary first. That's a class attribute. And then whenever I create a new bird, I can add it that way. Conversely, if we wanted to, and that actually has some benefits because now, right, I can just do like Tweety equals bird Tweety, and they're added to the aviary. And I'm not using inheritance here, but I'm using composition. I've created one aviary, but it's a class attribute that I'm using for all instances of my bird. So we can do it this way. If we want to, you know, we probably, if for some reason we wanted like different birds and different aviaries, maybe we do it this way. If we have 3 aviaries, maybe this is an argument we pass in, an instance of our aviary class, and the bird gets added to it. So there's a couple different patterns depending on what you want to accomplish. And I see a couple questions. I think someone's hand was up.
Yeah, my hand was up, but you addressed it as you went through it, so no worries.
Oh, awesome. Yeah, I hope that helps a bit. And honestly, I think with composition, in a lot of ways, like the simpler, the better. I'll often start out with a function. Like, and then if I feel like it belongs as a class attribute, I'll add it in. Landon, yes, sir.
Could you just put a print statement right where your cursor is for print parentheses Avery right below Tweety to print out like the enclosure for the birds?
Oh, what you want to see the aviary?
Yes.
Yeah, totally. Let's go ahead and do this. We're gonna have to do like aviary needs a dunder string method, right? So we can see stuff in it. So let's do dunder string. I'm gonna make this really simple because I'm feeling lazy. I'm not sure. Well, let's add. I'm not sure why I'm getting.
It looks the engine to
There we go. Yeah, let's just do for bird in self.birds. There's definitely more elegant ways to do that, but this way, when I print the aviary, it prints out all the birds. And we'll put two birds in the aviary. So, and in fact, the bird needs, I should probably give the bird, let's do represent. And actually this, I apologize, this is probably not going to work. So please ignore that. And I'll delete that in a moment. Return a string that has self.name. So now, whenever we need a string representation of the bird, we will use REPR. And let's do this. I'll just keep this simple. So let's print my aviary dot birds. And it would help, of course, if this was an F string. So there's a lot of different ways to do this, right? And let's see here, bird missing one argument because I didn't update my constructor. And kind of like in the code demo this morning, it's less, I think, about figuring out the best way than a way where you have confidence that you understand what the code is doing and that meets the requirements of what you need to do. Let me go ahead and talk a bit more about composition now that we're starting to see it, because we've seen inheritance. And inheritance is really powerful, but we don't always need it. So let me build out a little bit of an example with composition, and we can talk about it. And then I'll talk a little bit about how to identify when do I want to use composition versus inheritance. And really, the key is composition has a thing. It's a has a relationship. Inheritance is a relationship. A bird is a mammal. An aviary has birds, right? A rectangle is a shape. Or in the example that I'm about to build out right now, a car has wheels. And remember, it's okay to make really small classes. And that is in fact what I'm going to do right now. Let's say we want to make a car. I kind of know where I'm going, so I know I'm going to build an engine class, and it's going to be really simple. And I know that I'm going to build a wheel class. So when you're doing this, the way to know if I should maybe be reaching for composition or inheritance is think about, is this a relationship where something is something else or something has something else? And composition is super flexible and powerful. And one isn't better than the other. They just both do different things. And sort of like we saw with the bird and the aviary, and I'm catching up on the Zoom chat. And Athena, you're correct. Like we don't want probably bird inheriting aviary or aviary inheriting bird. And let me do, in fact, a little Python fanciness here to get 4 wheels. Which is I'm going to make a list. And I'm going to use a Python. I always forget the name of this construct, but I am telling Python loop through something 4 times. And each time do this and return this thing. So create 4 wheels for me. So this is the same as if I had done this. And it would help if I had my in statement there. And the car needs to start. And when the car starts, the engines of the car start. So I am composing my car class using my wheel class because a car has an engine, right? An engine isn't a car isn't an engine, a car has an engine. And when we drive, let's just return a message saying the car is driving. And I don't know, let's also, we might as well call our, well, all the wheels don't rotate, so we'll look at wheels rotating later. But I've got a method on my car class. I've got another method that uses this engine class that I've assigned to it. And so one moment, let me go ahead and make a car and then we can discuss this a bit. And actually, let me go ahead and let's see if I can't use the Python debugger. So let's throw a statement here, maybe a statement here, maybe a statement here, and let's see if I can't run this code. So there's going to be a lot of junk here, but actually, let me stick a breakpoint here, here. I just stick breakpoints everywhere because I'm not great at debuggers, to be honest. And let's add some watch. We'll just kind of watch. We'll just check it as we go. So I start my car. It goes to the start method because this is what we're calling. And because that is calling the start method on our engine, well, I needed to add a breakpoint here, so I apologize. Let's do this one more time and see if I can get it right. Yeah, I apologize, folks. I am not super handy with the debugger, to be honest. But we start the car. Yeah, I'll save
restart
it
it,
for
yeah,
another
you just have
day.
to hit stop.
Yeah, I'm just gonna save it for another day. I start my car. It calls start. That calls self.engine start, which is an instance of our engine class, which calls this method here, which returns this string engine started. I call drive, which then calls the drive method on here. And Saul, I know you had a question.
Yeah. So you can correct me if I'm wrong. I just want to make sure I'm not confusing this. This almost seems like the parent is kind of reaching out for attributes from its children. Would
No,
that be
because there is no parent or child class because there is no inheritance.
Okay.
Right? I'm not inheriting. Parent and child is car would inherit behavior from wheel. But I think you might be on the right path of understanding the way that the classes interact and use each other, but we wouldn't call that parent or child because there's no inheritance.
Okay. Okay.
But you're absolutely right that for the car class, we are using the engine class and creating an instance of it and assigning it here. Nathan, yes, sir.
Yeah, just to tack on to Saul's question. So if you had like a parent class that was like vehicle that had a wheels and an engine, and then the car would inherit those, and you could kind of have stuff specific to that kind of thing, to the vehicle, and then maybe like have like a tractor that would also inherit vehicle stuff. Is that kind of how that would flow?
Yeah, and let's use like the car as maybe an example of this. Like thinking about like inheritance being about is like what's maybe some child classes we can create that will inherit from car. Like what is a car? And I'll change car to like vehicle if it makes it easier to think about this. Or how about this? Four-wheeled motor vehicle. A truck is a four-wheeled motor vehicle, right? And I'm so sorry, I jumped way down here. And let's say that a sedan is a four-wheeled motor vehicle. And how about, is there a name for those cars that have truck beds? Is there like a formal that's not like about make or model?
Pickup truck.
Well, I've got pickup truck. Sedan, I'll just go for Jeep.
You could do a van.
Van. Yeah. So maybe our truck has a method put in truck bed. Right, and Roger, here I am going to use that pattern of I'm not going to worry about putting something in the truck bed when we create a new truck. And maybe the sedan has an open trunk method. And maybe the van has an open sliding door method. And you could expand on these, but a truck is a car, right? Or like a four-wheeled motor vehicle. A sedan is one, and a van is one as well. So let me make a truck. And let's start its engine. Right? And let's rotate one of its wheels. Why we'd want to rotate just one wheel is a question, a totally different question, but. And it looks like I have a typo or something going wrong in my code. Truck object has no attribute engine. So I made a mistake. And actually, this is a great thing to talk about. Truck object has no attribute engine. I created my truck. I'm inheriting. Why isn't there an engine? What did I forget to do here when I created my truck class?
You didn't bring that, you didn't call that, well, I can't see it now.
Oh, I'm so sorry.
Let
me get rid of this.
The super.
You didn't call that in
Yeah.
to truck? I can't see all of it, but it's okay. You get what I'm trying to say, I think.
Yeah, exactly. Exactly. I didn't call the constructor of my parent class that actually creates self.engine and self.wheels. If I do super that says, hey, Python, get me the class definition of the parent class of truck, which is four-wheeled vehicles, and go ahead and call the constructor of that class. Now let's see if this works. Let's see here. Takes one. I don't have to pass itself. I think it will do that for me. And there we go. Though I would have expected a print statement when I start my truck. Oh, because it just returns. It's not actually printing anything. So it took a little bit of a journey, but now we can make a truck and we rotate the wheels, right? And the key thing here is I need to call the constructor method, the dunder init method of my parent class. And Python gives us a handy dandy built-in function named super that will get the parent class definition for us. So this is composition in action and inheritance, in fact, and you can use them both together. And to kind of recap a little bit about sort of when you want to use these and some key differences. car has wheels, right? A car has an engine. And with composition, you get flexibility, right? There's a lot of flexibility you get with composition. Inheritance, truck is a type of car, right? Or like a dog, dog is an animal. And with inheritance, you can establish relationships. You get more code reuse, structure, and hierarchy. And this is actually written out a bit better in our curriculum doc, to be honest, that I'm really doing it justice. So let me just quickly kind of walk through a bit of that. And then we'll look at the last thing for us to see, because I realize that we are at time, which is called polymorphism. And I think since we've been building up to it, once you see it, it'll be relatively straightforward. And let me exit the full screen here. Apologies here, one moment. We'll just actually do this. Sorry about this, folks. So when do I want to use what? Composition versus inheritance. When there's things that are distinct and have separate functions, like if you think about the car manager problem yesterday, the terminal and all that stuff is kind of separate from the car manager. It's easy to maintain, it's more flexible. Inheritance does kind of lock you in. When you can see like a clear hierarchy, and that one thing really is like a car, like a bird is an instance of an animal. You've got species, like if you can kind of draw a tree of these things, then that's a sign that you might want to use inheritance. It can help with code reuse, and it can establish common functionalities. They're both useful tools. And again, think about the aviary, right? To go back to the example that we started with, if we go all the way down to our aviary code, like a bird belongs to an aviary. An aviary has birds, but if, it doesn't really make sense for a bird to inherit the aviary class, or for the aviary to inherit the bird class, because one does not depend on the other. And it can take a little practice, but if you think about like, is this is a relationship or a has a relationship, I think that will help lead the way. And also you'll find like some approaches make it a little easier than others. Like if you're doing one approach and it feels like you're kind of fighting the code, then maybe that's a sign that you want to take it in the other approach. So the last thing I want to talk about is polymorphism. And this builds on everything that we've been discussing. So there's a couple things to note here. And I apologize, folks, that I'm going to run 10 minutes long, but we'll be done at 12:15. So I apologize, I'm running a little long here. Polymorphism is about, I want the same interface for different classes. And so maybe I have an animal class. And it has, I'm not even going to give my animal a constructor for just the purposes of teaching this. And actually, I don't know why we have that there. But let's say the animal has a speak method. And all our animals sound like a cat. This is not that useful, right? Let's say I want to make a dog class that inherits from animal. And I want the dog to be able to say something else. The cat, I don't need to change because the animal's default speak method does what I want. And then let's also make a duck. So when I inherit the animal class, it has a method named speak, but I can override it. And this is called polymorphism because different things respond to the same method call in different ways. Right? And this is the advantage. And we'll do dog. So I have all these different animals and they can speak. And let me go ahead and kill my other print statements real quick. Perfect. And I'm going to need to print these because they're just returning stuff. And I apologize, folks, for some reason the terminal. There we go. So why do I care about making sure that I have the same method for each of these classes? Right? Maybe instead of an aviary, I have a bestiary of a whole bunch of different animals. If I know that all of my animals have this same named method, have the same interface, I can write code to do stuff with them. Right? And you'll hear this sort of talking about like the interface of a class. So if I can create a bunch of related classes that have the same named method, then I can do stuff with them. And again, there's more than one way to accomplish this. You all saw me doing this before, where when you define the duck in the constructor, you pass in the sound you want it to say. And there's not necessarily one right way of doing it. But this is the basic idea of polymorphism. So I just want to check in and see what questions folks have. Saul, yes, sir.
I noticed that in your classes, like duck and dog, you didn't call for a super in it, but it still takes that the attribute of speak. Like for example, in cat, you don't have a super in it. How is it calling for the parent class without the super?
Yeah, that's a great question. What the super does is it does whatever is in the constructor of the parent class. We still get the inheritance behavior of these methods. If I gave my animal class a init method and self, let's say maybe the animal has a name, and this returns an F string. So a bunch of things are going to start going wrong here, right? For my duck. And let me just comment out all this stuff for the moment, so we can just see one error at a time. I don't know. For some reason, I want to name the duck Tim Robbins. And let me comment out that other line of code. So, well, the issue here actually is, I apologize, I'm overriding this. It gets a little more complicated to demonstrate, but if we did maybe actually Quack says self name, and this needs to be an F string. Jordan, I see your question. Just for a moment. So yeah, actually, I'm not gonna lie. That is a good question. I'm not sure what's going on here with the behavior of the duck. I actually would have expected us to get an error here, not calling like the super, and not calling the super init value. So let me get back to you on that, Saul. That's a good question. I thought this was gonna throw an error. Jordan or Yams, what's up?
Yeah, I was just going to piggyback off of that. It's just, I thought I understood that you didn't need to pass super because it didn't need to inherit any attributes, but it looked like the methods were being passed off just by default. But now, since you ran into that duck, looks like.
Yeah, the methods are passed by default. I'm a little surprised that this worked. Maybe it's because we don't have an init method here. If we do this, I don't know what's going to happen. I mean, a bunch of things are going to happen. For one thing, if I don't include name there, it won't work. So now we get what we expect, but it does appear if I don't, and this kind of makes sense. Maybe what Python does, if for a child class, I don't define a parent constructor at all, it just uses the parent constructor automatically. I honestly don't recommend it. I just recommend always make a dunder init method, and then with inheritance, always do super, because otherwise it is going to cause too much confusion, and there's not enough like times where this is where you want to do this. So I would recommend just always make a dunder init method. If you're doing inheritance, always do super. And I just need to actually call super like a method. But yeah, that actually did catch me by surprise. Which also goes to show like these languages are complex and have a lot of different features, which is also why once you have a pattern that works for you, it's good to follow it. Like, the goal is not to know 1,000 tools, it's to know the 5 most important tools really, really well. I see a question in the chat about polymorphism. Yeah, Francisco, thank you for jumping in there. Polymorphism is really about like inheritance. And the last thing I want to show with polymorphism before we wrap is using something called an abstract class. And this is a bit more advanced. I don't believe this is on the assessment, though Francisco can correct me if that's wrong. And we do need to import some stuff from the Python standard library. ABC stands for abstract base class, and we're about to see what that means and how we use it. And let's say we're going to make a shape class, and we're going to use inheritance for a rectangle. And a circle. Right, because we know that a circle is a shape, a rectangle is a shape. Inheritance is a good fit for this use case. And we're going to build constructors for all of these things. But let me show you what it looks like to use this sort of helper called an abstract base class. And it introduces another decorator named abstract method. I get to define the interface for all of my child classes. I want to say I want all of these child classes of shape to have a method named area. Shape is the abstract sort of design. It's the blueprint of the blueprint. But the details of what area should do are going to be different for each child class. So this is something that can help us use polymorphism in our object-oriented design. Right, and so for my rectangle, the way I calculate the area is I do width times self height. And for a circle, we're going to have self, and we're going to have maybe radius. We're going to square the radius, raise it to the second power. So let me just run this code and then talk a little bit about what the abstract base class is doing for us. Right, and we'll ignore this quack message from before, but the 20 is the one that we care about, because that's us calculating the area of our circle 4 times 5. And let's see what happens just for the sake of argument if my rectangle doesn't have an area method at all. Oh, and it would help. Yeah, that's exactly the area that we want. So I'm creating a rectangle. I'm passing 2 arguments to its constructor, width and height, which is exactly what we want. I've got this. I haven't done super, and there is no constructor here in shape, so that it's a little less relevant. But I'm getting an error, and the error says, can't instantiate abstract class rectangle with abstract area method. So rectangle inherits from the shape class. But let's see if they have a nice definition for it. Yeah, they don't get into it. It's a little, this is a little too dense. But my parent class, like I am never going to create a shape. I'm never going to create a shape directly. It doesn't exist, right? In our universe that we're designing in our code, like I would never create an instance of the shape class, but I want this abstract shape class so I can inherit it for my other shapes. So I want this to be an abstract base class, and I want every shape to be able to give an area, right? And I could do circumference as well, right? That's another great example of an abstract method. Like every shape must have a circumference. And for a rectangle, I think circumference would be what? Return width times 2 plus 8 times 2. And of course, I need to say self. Right? Every shape I'm going to create, I want to be able to always know that any shape I make will have a circumference and an area. I don't need this. My code would work if I just did like a normal shape and we did polymorphism the way we saw here. But here, my code enforces some rules. It complains if a class that inherits from my abstract base class doesn't have these abstract methods. So that's the last thing I wanted to cover. And I know I ran long here. So I really appreciate you folks sticking into our lunchtime. Hopefully sort of seeing this example of polymorphism has helped show another tool in the toolbox. And in its simplest form, it's really straightforward because it uses the inheritance we know and see, and we can just override an existing method. There are not many times when you'll have to like create abstract base classes and do all this, but this is just digging a little deeper into a lot of what object-oriented programming can offer in terms of like creating the structure and rules and shape of our applications. We'll break for lunch in a second, and then I'll also tackle questions. But just to sort of recap and hit on some important points, composition and polymorphism are both useful, as is inheritance. Composing objects from smaller components is really, really useful. In some ways, composition is almost more useful than inheritance because it's so flexible, right? Inheritance, you're locked in a little bit. This approach with the car using the wheel, the engine class, but not inheriting it, right? We're composing our car class using these other classes, gives us a lot of flexibility. Inheritance works great. It locks you in a bit more, but when you know you have like a clear hierarchy between the different parts of your program, a rectangle is a shape, right? A bird is an animal. Inheritance can be very, very powerful and save you from having to duplicate code. So thank you all very much. Let me stop the recording and we'll wrap, and then I'll take some questions. Or actually, we can just keep the questions on the recording, but let's break for lunch, and I'll get pairs out for pair programming in the next hour. If anyone has a conflict and is unable to pair, let me know, and I'll put you in a trio. As always, encouraging you to pair, even if it feels a little uncomfortable. If you'd rather be in a trio, just let me know. But please do message me now so I know I don't get pairs out within about the next 30 minutes. Yes, what's on people's minds? Andrew.
So my question is the abstract method being called when a child class object is instantiated? So as soon as you pass a rectangle in or create a rectangle, it's automatically returning the area of that?
No, it's not being called. What's happening is as soon as I create a rectangle, Python says, cool, let's create an instance of the rectangle class. Oh, rectangle inherits from shape. Let me do the bit of Python magic that I do to like give rectangle the methods from shape and stuff like that. Oh, wait a minute. Shape is an abstract class. There are some different rules here. I'm not going to call and run these methods, but I do need to make sure that these methods exist when I'm creating a new instance of the rectangle class. And if they don't, we get an error. But and then if I want to call it, I still have to actually call it like any other method like that. So it's not that this method gets called, it's that when an instance of this class gets created, it has more rules that about how it has to be. And Python doesn't look at those rules until we try to create an instance of the class. Like some compiled languages like Java that have this intermediate step, but because Python is like a dynamic language, like the Python runtime isn't going to, it's not until you run your code and Python gets to like, oh, let's deal with this rectangle class that it says, oh, I'm trying to do something that breaks the rules. Does that help a little bit?
Yes.
Awesome. And someone else had their hand up, and I'm not sure where it went. But
Adam,
what?
I had it up, but when I was missing, I was just following along, and when I included the super init method within the rectangle that has the parent class shape, when I put super in it, it force typed those abstract methods into the class rectangle. Is that what the abstract method is supposed to do? It's supposed to remind you or tell you you have to have those in there.
Can
And
you share your screen so I can see the code?
yes, I can do that. That's the wrong. Oh, this is the right screen, right? Can you see cursor? I when I included the super in it, when I went to define circumference myself, it pulled it through. Is that it's pulling through because it's an abstract method?
Do you want to have super.area on line 123 and super circumference on line 125?
123.
Because what those do is what you're saying is, hey, rectangle, the way I'm defining the area method is go to your parent class shape and call that method. So that is introducing extra behavior. So
Okay.
I'm not quite sure. Like, are you asking what if you get rid of the area and circumference methods entirely on the rectangle class?
Yeah, I guess I'm asking is when you like it, are you supposed to include this to enforce that this rectangle class has these in here?
No.
Like, okay.
Yeah, you don't have to. I don't know off the top of my head if we would really want an abstract base class to have a constructor. Super init is more about calling the parent's constructor. I will also say I am not sure what your area and circumference methods will actually do if you run them.
Okay.
It may throw an error because you're trying to call the area method on the parent class, which is the shape class, which is this abstract class, and that method does nothing right now. So those may just not do anything.
Okay. All right. Thank you.
Yeah, totally. What else is on people's minds?
Adam, would it be accurate to say like there is no init method in the in his super class? Is that what the actual error that is like being thrown? Because there's no init method.
The error that's being thrown when I run my code or when Landon runs his code?
On Landon's, yeah.
I did not look at the error that was thrown because that's
okay.
not what we were talking about, so I don't know. But what I would suggest is if you guys want to experiment with that code and run it and have an error message that you want to chat more about, we can look at that. But do you have a question around like how to use the init method, or does one belong here, or around sort of like abstract classes and stuff?
No, I was just asking if that's, or at least that's what made sense to me, because the super, it's trying to run a method that doesn't exist in essence in the super class.
Yeah, I would be cautious because like my rule of thumb is you need to run the code and confirm that the error message is from the current state of the code. Like, did we modify something in the code that we were looking at between when we last ran the code or not? Do we even know that that error message is there? Like, you can't, it's real, this stuff is too complicated to kind of dig into it that way. Like, and there were like 3 different things going on there, right? Because we had added super init and we were calling this, which is going to possibly introduce other behavior. And we were doing that here as well. So there's at least 3 different things going on that are different from what we're talking about here that could all have different effects. So it's like we can look at and debug a like specific thing there, but it's just too complex to try and like look at and draw a general conclusion from. Like the rule of thumb, like with debugging, is you have to change just one thing and run your code again and see what happens. Otherwise, you don't know what's causing what, right? So whenever we're like discussing or analyzing code, like we got to do it just one at a time. Like if we want to, what we could do here is we could do super dunder init, right? And call that. And so now we could run this and we create a rectangle and we can call this circumference method and we can see what happens. And nothing is printed out. Actually, I should print this out and that would maybe help. And I'll uncomment this as well. So I get circumference and area here, right? And this doesn't seem to affect anything, which would make sense because there is no dunder init method here at all. So this is calling something that doesn't exist. But then what we also had was super area and super circumference, right? So we've added one thing, we've changed one thing and ran the code to see what happened. Let's change one other thing and see what we get now. And this runs fine, but it returns none and none because these methods don't do anything.
Right. Okay. Yeah, that makes sense.
Yeah. So hopefully that helps explain a bit more. And that's also just why I know I went into a bit of detail there, but just to share, like sometimes why I'm very like cautious in answering questions about like program behavior or what causes what is because there's just too many moving parts. So it's like we have to just make sure we're taking the time to like understand what we're trying to analyze. Otherwise, we could be looking at 3 different things interacting and causing issues because, you know, if we change those things, but maybe I also, you know, removed an argument from my rectangle constructor, that's going to throw an error. But this error has nothing to do with any of this stuff with super or init or anything like that. It's from this one right here. Yeah. So like as you're digging more and more into code, and these are all good questions, just make sure that you're making one change at a time and observing the results. Just like kind of they say with like the scientific method, like when you run an experiment, you have your control and you make one change and you observe the results. Otherwise, like if I change two things and I run my code, I don't know what caused the change in behavior. And it's definitely a habit that can take a little while to build up, but it's super, super useful. Let me go ahead and actually stop.